the degree of the alcohol or the degree of the carboxylic acid will actually tells you about the rate of the esterification reaction. Now in this case only the question is that reaction is reversible in nature. Now if you want to convert this reaction into the forward direction, what you need to do is you need to remove water as soon as it is formed. So for that removal of water, what we need to do is we will follow some alternate pathway to form the esters. So for that matter, what we do is that there are two methods actually by which we can convert this direction into the forward direction. You add benzene as a co-solvent. When we say co-solvent means additional solvent. So what we do is that we have a water which is being eliminated as in the esterification reaction, and you are adding benzene. Now this benzene and water forms actually a azeotrope. So azeotropes it form, and which has a boiling point. The benzene and the water azeotrope has a boiling point of 69 degrees Celsius, which is highly achievable in the laboratory conditions. So therefore what we do is we remove H2O as soon as it is formed by adding benzene as a co-solvent and keeping the conditions or the temperature of the reaction at somewhere 69 degrees Celsius. By this way we are able to convert this reaction to the forward direction. The other way of converting this reaction into the forward direction is that you convert carboxylic acid, that is RCOOH, to RCOCl. We convert carboxylic acid, that is RCOOH, to RCOCl. Now once you convert this, what happens is RCOCl reacts with the alcohol and it forms ester with the release of HCl molecule. And basically HCl molecule does not cause any reversibility of the reaction, or does not cause the reaction to be reversed. So therefore in that case also reaction is being converted into the forward direction. Now how do we convert carboxylic acid, that is RCOOH, to RCOCl? It is basically done by three methods. Either you add PCl5, or you add PCl3, or you also can add SOCl2. So basically all these three are the chlorinating agent for the organic chemistry. So what we do is we add either PCl3 or PCl5, or we add SOCl2 in the carboxylic acid, that is RCOOH, and hence it forms RCOCl. It forms RCOCl. Now this RCOCl actually reacts with the RCOOH. This RCOCl reacts with the R-OH, and hence it forms ester, that is RC double bond O, OR dash, and HCl is being eliminated. Now again, if suppose we are using 3 degree alcohol in this reaction, so let us understand this now through an illustrative example. The example is something like we have CH3COOH as a carboxylic acid first of all, and we are converting first of all into the RCOCl, that is CH3COCl. So what we will be doing over here is we will add PCl3 or PCl5 or SOCl2 in RCOOH to form RCOCl. Now once RCOCl is being formed, then that means in this case it is this CH3COCl is being formed. Then we are reacting it with a 3 degree alcohol. So 3 degree alcohol is, we have something like CH3 whole thrice COOH. Now when you react these two, what we get is CH3, C double bond O, C, CH3 whole thrice. Now HCl is being eliminated in this step. Now basically what happens is the further protonation takes place. And in that further protonation what happens is that this O atom, which is singly bonded, actually gets protonated by the H plus of the HCl, and hence it forms RC double bond O, OH positive, and CH3 whole thrice. Now actually what happens is that there is a high possibility that this OH plus now, or you can say the bond between O positive and the C atom undergoes a decomposition. By undergoing a decomposition in this case, what is being formed is CH3CO OH plus CH3 whole thrice C positive. Now this carbocation actually is a tertiary carbocation. So due to the high stability of the carbocation in this reaction being formed, due to this actually what happens is that the HCl which is produced in the reaction is undergoing a further reaction, and hence finally what happens is that Cl minus we have, that Cl minus will attack on this C positive carbon and forms CH3 whole thrice CC.